Hi, I'm Keith Johnson, and this is the Black Hole Lab Report. I'm from Lab M08. In this lab, we were given position data for a star orbiting a black hole. My data was in a roughly elliptical orbit. In this system, the only force acting is the force of gravity, which is proportional to the two masses, that of the star and the black hole, and the distance between them at any given moment. This force can be split into parallel and perpendicular components. The parallel component is equal to the change in momentum, and the magnitude of momentum, over the change in time. And the perpendicular component is the magnitude of the vector, the momentum, times the change in direction. At any given moment, the F net points towards the black hole. Perpendicular is perpendicular to the motion, which is in the direction that the star is moving, which is F parallel, is in the same direction. If we put this into Python, we can model the forces with the red arrow being F parallel, the blue arrow being F net, and the black arrow F perpendicular. As it gets closer to the black hole here, it speeds up significantly as the force increases, pulling it faster through this end of the loop. The what does it mean question was, how are Fnet and dp/dt related? By the momentum principle, they are the same thing, and each aspect of Fnet is the same as its corresponding aspect of dp/dt. So F parallel equals dp/dt parallel, and F perpendicular equals dp/dt perpendicular. The what if question was, what if we replaced the black hole but the motion didn't change? Would we be able to tell the difference? The answer is no. In order for this motion to remain the same with a different black hole, the black hole would have to be of the same mass as the original star. Otherwise, the force would be greater and the speed would increase. If there was a larger mass, the orbit would take a much larger path as it was rocketed faster through it, because the force would be greater than it was with the smaller black hole. Also, as a side effect, the gravitational effect of the star on the black hole would be smaller, and its own changes would be smaller, but that's not terribly relevant to this lab. Well, thank you for listening.